So our second lesson says converting vertex form to standard form. Okay, we talked about the vertex form, and we said that the vertex form looked like this. Look like walls a bracket x minus h squared plus k, where a, h, and k are numbers, right? A cannot be 0, h and k can be whatever. Okay? Now, what is the standard form? The standard form is a form that looks like this. Y equals squared plus bx plus c. So if you go back to what we just did earlier, we wrote this right here. This is what we call the standard form. Right? This looks like exactly like this. Y equals ax squared plus bx plus c, where a, b, and c are numbers. Okay? So the standard form is the expanded form. Okay? The vertex form, do you guys not have these notes, or do you have them? I see people flipping papers. You have them? Okay. The vertex form is what we learned in the previous unit. And now we're going to learn how to go from the vertex form to the standard form. Okay? Now first let's look at some characteristics of both forms. Now I want you to look at both of these graphs and tell me, what do you notice about these graphs? They're the same? Do you guys notice that they're the same? Do they have the same vertex? Okay. Do they have the same y-intercept? Do they have the same opening? Okay. So they are the same, except what you see here, you see that this equation is y equals x minus 2 squared plus 1, while this equation is y equals x squared minus 4x plus 5. Okay? So yes, I entered two different equations into the graphing calculator or the Desmos, but I ended up with the same graph, which means this equation and this equation are exactly the same thing, except one is written in what form? Vertex form, and the other one is written in standard form. Now, vertex form, what can you find from vertex form? The vertex, which is what? 2, 1. The vertex is 2, 1. We just did the test yesterday. The vertex is 2, 1, yes? And I can find it from these two values. Okay? Can you tell me what the vertex is from the standard form? No. But what can you find from the standard form? What important points on your graph or key feature point on the graph that matches the y-intercept? So if you look at the y-intercept, which is right here, it's at 5, right? So the y-intercept is at 5. And what value of the standard form matches the y-intercept? Which one? A, B, or C? C. And that's always going to be the case. When it's in standard form, your number, which is C, right, the one that does not have a variable, is your y-intercept. So this is your y-intercept. So the vertex form is good to tell you where your vertex is, axis of symmetry, minimum value, maximum value, which direction does it open, step pattern, all of these great things, okay? Standard form is only good for the y-intercept, okay? Here's what we're going to do here. So an equation in standard has the y equal y equal ax squared plus bx plus c tells the location of the y-intercept. An equation in vertex form. Can you guys state the vertex form for me? Y equals a
bracket x minus h plus k
squared plus k. If you miss the squared, then it doesn't become quadratic. Tells you the location of the vertex, axis of symmetry, and optimal value. Remember that all these two things, the optimal value and the axis of symmetry, they relate to the vertex. Now, the question is, how do I convert from vertex form to standard form? In this course, we only learn how to convert from vertex to standard and not the other way around. Okay? So, the process is called expanding. It's the same thing as what we did earlier. So, if you're going to expand this, eyes on me for a second. So you have y equals x minus 2 squared plus 1. How would you expand this if you were to expand it without me telling you? What would you do? Multiply what? Write x minus 2 twice, right? So you would want to write x minus 2 twice because it's x minus 2 squared, right? So you're going to write x minus 2, x minus 2. What do you do with that plus 1? Keep it outside. Don't worry about it right now. Just leave it there. Okay? So, you write the x minus 2 twice. Now, you're going to expand using the FOIL method that we just did. Okay? Then, we're going to deal with the plus 1 after. Okay? So, let's do that. Expand means FOIL, which means first, x squared, then negative 2x, negative 2x, plus 4. Now here is my plus 1 that I'm going to have to write and I can't forget about. So now you write that plus 1 here. So you see right now that I can collect my like terms. Now I have more than one like term. I have these two. That gives me negative 4x. And I have these two, which is going to give me plus 5. Okay? Now, if I want to go back here, just one second, I'll come back to this. X squared minus 4x plus x squared minus 4x plus 5, right? This is, I got the right answer. So, same thing as what we did earlier. I'm expanding, I'm foiling. Okay? But I have that plus 1 that I have to not forget about and add at the end. Are we okay with this? Okay. Now, given the equation for a quadratic in vertex form, y equal negative 3 bracket x plus 1 squared minus 4. So this is the vertex form. Can you guys tell me what the vertex is? Negative 1 and negative 4. Okay. Which way does it open? Down. What's your step pattern? It's negative 3 times 135, right? Because remember your A value, right? So it's negative 3 times 135, right? Which is negative 3, negative 9, negative 15. Okay. Now let's go here and let's see what the question is. So the question is the following. State the key feature you can determine from the vertex form. Expand, then state the key feature you can determine from the standard form. So remember that the equation is y equal negative 3x plus 1 squared. Is that the question that we just asked you for? Plus 1. Okay. Plus 4. Oh, minus 4. Okay, so what can you tell me from this form? So, okay, we have, it's not asking me for transformation, it's just asking me for key feature. Okay, so what's your vertex? Negative 1, negative 4. Axis of symmetry? X equals negative 1. Optimal value? Y equals negative 4, and it's a minimum because is it going to open up or down? It's going to open down, right? So it's a max. Okay. And then you can state if you want the step pattern. But technically, these are the key features. These are the 3 things that we need to state. Okay? Vertex, axis of symmetry, optimal value. Anyone doesn't know this from the previous unit? Okay. Now it's asking me to expand. It's kind of similar to what we did, but there is an extra step here. Okay? So let's see what we're going to do. Sorry? What's the first thing I need to do to expand? So write the x plus 1 twice. Okay. Then what do? Do the FOIL. These are the steps that I always want you to follow. You're going to write your bracket twice. You're going to FOIL. Okay? So x times x gives me, so you write exactly the same thing here, and then you open your bracket. X times x gives me, x times 1 gives me 1x. 1 times x, 1 times 1. Close your brackets, put your negative 4. Okay? So the first step is I did my FOIL. Now, BEDMAS tells you when you do your FOIL, what do you do after that? Brackets. So I have 2 options here. You can either simplify inside your bracket first, or you can multiply the 3 in. I'm going to multiply the 3 in and do my simplification in one step. Okay? So I'm going to multiply that negative 3 in by using distributive property. So that negative 3 is going to multiply to each term inside the bracket only. So negative 3 times x squared. Negative 3 times 1x. Negative 3 times 1x. Negative 3 times 1. Minus 4. Right? That minus 4 is not affected. Now let's collect our like terms. What are my like terms? It's negative 3x and negative 3x. So that gives me negative 6x. And then I have negative 3 minus 4, which gives me negative 7. That would be my expanded form.
So the answer, wait, negative 3x squared?
Yep.
Minus 6x minus, okay.
That's right. That's your final answer. That's your trinomial. Does this look like it's the standard form? Ax squared plus bx plus c? So, FOIL, multiply your a into the bracket, collect your like terms. FOIL means first, outer, inner, last. Like do this. Okay? So, FOIL, multiply a into bracket, collect like terms. If you don't have a, then you skip the second step. Now, what key features can you tell me from the standard form? From the standard form, what is your key feature? Which is y equals negative. So my y-intercept, which is y equal -7, and I can find that from my last term. Okay, so you got 3 things that you're going to work on. I think they're A, B, C. Yeah. One thing, guys, before I let you guys work on this, what is your A value here? -1, right? You have a -1 right here. Okay?
That's in front of the x, yeah? Or in front of the bracket?
No, this is outside the bracket.
Outside?
Yeah. So it's like this. -1 x minus 1 squared minus 4. Okay? Okay, so I'm going to let you guys work on this. Show me what you got, then you can go. Your homework for, if you haven't got the pink sheet, I'm going to go photocopy more of the pink sheet. Your homework is page 2, 3, and 4.